Good evening, children. Our next topic, pH scale. So, the question will arise in our mind, what is pH scale? As the name itself indicates, it is a scale. Understood? It is a scale having numbers on it. Understood? Yeah. This is a scale like a centimeter scale, isn't it? Ruler, centimeter scale. Ranges from 0 to 100 centimeters, isn't it? Like that, pH scale is also scale which ranges from 0 to 14. pH scale is a scale which ranges from 0 to 14. And what the midpoint of 0 and 14, children? We know 7. Isn't it? pH scale is a scale which ranges from 0 to 14. Like we use ruler, that is scale to measure the length of any object. A question arises, okay, we understood pH scale is a scale ranges from 0 to 14. What it is used for? It is used to measure strength of an acid or base, pH scale. Now, you know, children, go to our previous topic, indicators. We studied 3 types of indicators. What are they? Litmus paper, methyl orange, phenolphthalein. Yes or no? What are they? Litmus paper, blue or red color. Then what did we study? We studied phenolphthalein. Then what did we study? Methyl orange. So what do they tell us, children? They tell us given chemical is an acid or basic. Given solution is acid or base. They tell us, that's it. Whereas they don't tell us strength of an acid or base. What do? They do not tell us relative strength of an acid or base. To measure the relative strength of an acid or base, what do? We take the help of pH scale. Once again, children, what is the help of these 3 litmus paper, phenolphthalein, methyl? They tell us whether given chemical is acid or base. They do not tell us how strong is acid or base, or they do not tell us relative strength of acid or base. To measure the relative strength of acid or base, we take the help of pH scale. pH scale is a scale. It was devised by a chemist by name Sorensen. Sorensen is the name of the chemist. Sorensen in 1909. He devised this scale, which consists of numbers ranging from 0 to 14. Midpoint is 7. Okay, children. Now, with the help of this, we can measure the relative strength of an acid or base. Now, pH, most important, children, remember, pH is inversely proportional to hydrogen ions. Concentration of hydrogen ions. pH is inversely proportional to hydrogen ions. Concentration of hydrogen ions. What does it mean, children? What does it mean? Higher the pH value, lower the concentration of hydrogen ions in the chemical. Take a chemical, its pH value is high. Inversely means what? If pH is more, concentration of hydrogen ion will be less. If pH is less, concentration of hydrogen ion will be more. pH is less means concentration of hydrogen ion is high. pH is more or high means concentration of hydrogen ion is less. They are inversely proportional. One is high, other one is less. A chemical has large amount of hydrogen ion concentration, then its pH is less. A solution has less concentration of hydrogen ion, then pH is more. Take for HCl. What is HCl? HCl is an acid. It will have large amount of hydrogen ion. Yes or no? So its pH value will be less. Take NaOH, children. Example, NaOH, KOH, MgOH, CaOH twice, NH4OH. They contain what? Hydroxides. They are bases. What the concentration of hydrogen ion? See, children. One more thing. I'll finish it. NaOH is a base. It will have less hydrogen ion. So its pH value will be more. So hydrochloric acid is an acid which will have more large amount of hydrogen ion concentration. Its pH will be less. See, children, now HCl is an acid. It doesn't mean that it doesn't contain hydroxide ions. Though it contains hydroxide ions, concentration will be less. It has more of hydrogen ions. So its pH will be less. Here, NaOH is a base. It doesn't mean that it will have less zero hydrogen ions. It may have hydrogen ions, but will be very, very less. Understood? Take for example water. Water. Pure water means pure water. What is water? H2O. H2O. When it undergoes ionization, what do we get, children? We get hydrogen ions and hydroxide ions. We'll put equal. It will have equal amount of hydrogen ion concentration as well as hydroxide ion concentration. Now, just now we discussed HCl and NaOH. What is HCl, children? Hydrogen. Sorry, HCl is an acid because it has got large amount of hydrogen ions. What is NaOH, children? It's a base because it has large amount of hydroxide ions. What about pure water? Pure water is one which has equal amount of hydrogen ions as well as hydroxide ions. Or we can say concentration of hydrogen ions or hydroxide ions are equal. Therefore, pure water is neither acidic nor basic. It is neither acidic. It is neither acidic nor basic. Then what is it? It is neutral. It is neutral. Understood, children? In pure water, you add acid. What happens? You add some amount of acid in a beaker. Take water, add little acid. What happens? Hydrogen and concentration will increase. So then it becomes slightly acidic solution. Its pH will vary. Vary means change. Similarly, in another beaker, you take hydroxide water and add little amount of base, sodium hydroxide. What happens? Concentration of hydrogen ion will increase. Now what do we say? The solution has become acidic. It's no more pure water. In first beaker, we taken water, add a little HCl, it becomes acidic, pH will vary. Here also in second beaker, we have taken little water, added base. What happens? Concentration of hydroxide ion will increase, it becomes basic. So on this pH scale, we can measure now the relative strength of acid or base. Why? Because the normal indicators, they do not tell us the relative strength of acid or base, or they cannot tell us how strong or weak acidic or basic solution is. Come children, come back to pH scale. pH scale, what is the midpoint? Midpoint is 7. Midpoint is 7. Yeah. Now what did we say here? pH is inversely proportional to the concentration of hydrogen ion. Pure water, what is the pH? 7. 7 is neutral. 7 is neutral. Understood, children? As we go above 7, means what? pH is increasing. What do we say here? pH is inversely proportional to hydrogen ion concentration. pH is more, hydrogen concentration is less. Hydrogen is present in which chemical, children? Acids. Yes or no? Now it is basic. Higher the pH value, lesser the concentration of hydrogen ion, basic the solution. As the pH decreases from 7 to 0, what do we say, children? It is slightly acidic. Not acidic, acidity goes on increasing. That's it, children. pH. What is the full form of pH? In this word pH, P stands for potence. Potence. This is derived from German language. Potence. What we say potential? That is energy, takat. P stands for potence. Potence or potential of what? Hydrogen ion concentration. So pH is inversely proportional to hydrogen ion concentration. Understood, children? Look at the scale here. Now, as the pH exactly 7, pH of a solution, it is neutral, neither acidic nor basic. Example, water. As the pH increases from 7, concentration of hydrogen ion decreases, means concentration of hydroxide ion increases. Otherwise, therefore, pH it will be basic. From 7, if the pH decreases, what happens? The the acidity increases. Concentration of hydrogen ion increases, pH will decrease. Once again, from 7, pH increases, it becomes basic, pH decreases, hydrogen ion concentration decreases, it is a strong acid. That's what children. Understood? Now, from exam point of view, this question will come. So, there is a chemical A whose pH value is 13.5. What is it, children? Above 7, basic. Now, there is a chemical B whose hydrogen whose pH is 5.6. What is it, children? Acidic. Now, there is another chemical C whose pH value is 9.2. What is it, children? Basic. Don't get confused. There is another chemical D whose pH value is 1.5. These two are bases. These two are acids. Now question is, see, MCQ, many children say that MCQ is very easy. I call it as leg pulling question. They pull your legs. They will ask A, B, C, D are 4 chemicals whose pH values are 13.5, 9.2, 5.6, 1.5 respectively. Which is strong acid? Which is strong acid is asking children. As the pH decreases, acidity increases, concentration of hydrogen ion increases. Yes or no? This definition, please remember. pH is inversely proportional to hydrogen ion. These are not acid, they are bases. This is acid, this is base. What's my question? Which is a strong acid, children? D, whose pH value is least. Of all 4, D is the one which has least pH. It is strong acid. Now it reverse the question, children. Among the following, which is a strong base? Which is a strong base? What is base? One whose pH value is more than 7. More than 7, not 7. 7 is neutral. Which is that? Above 7. As the pH value increases, stronger the base. As the pH value decreases, stronger the acid. Now which is the strong base? A, because its pH value is 13.5. Again, many children get confused. Here, out of B and D, both are acid. Which is strong acid? D, because pH is there. Similarly, if I ask the same question, which is a strong base, many children will tell the one which has 9.2. No, children, wrong. One which has higher pH value, strong base. Which has lowest pH value, which is the strong acid. Understood, children? This one question will come for 1 mark. This is the concept you should understand. Understood? Okay, this is the end of this. Dear children, our next topic, universal indicator. What is that? Universal indicator. This is a continuation of pH scale. Already we studied indicators, children. I revised in the previous topic pH scale. What is that? Indicators, common indicators. I am talking about which we studied in the first topic, previous topic. What is that? Litmus paper, methyl orange and phenolphthalein. Yes or no, children? This is the universe. They tell us what? They tell us given chemical is acid or base. Okay, children. Now, this universal indicator. What is indicator? Indicator is a colored substance. Colored substance. That's a dye. What is dye? Dye is a colored substance. What happens when universal indicator added to the chemicals? They show change in color. When universal indicator is added to chemical, be it acid or base, they show different color. Understood? Now, what do we do? On the pH chart, which has different colors and different pH value. Different colors and different pH value. What did we study in the previous topic, children? pH is inversely proportional to hydrogen ion concentration. So, when we add universal indicator to a chemical, be it an acid or base, it shows change in color. So, the universal indicator shows different color sets, different concentration of hydrogen ions. It shows different colors and different pH, which pH depends upon what? Concentration of hydrogen ions. Less hydrogen ion, high pH. Less hydrogen ion, high pH. More hydrogen ions, concentration, low pH. Now, universal indicators show different colors at different pH, means the universal indicator will show different colors at different concentration of hydrogen ions, children. This is the concept don't get confused. Now, look at children. I have written a chart. Previous topic, what did we study? pH scale, which ranges from 0 to 14. I made 2 columns because there is no space in the board. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This is the range of pH scale. Yes or no, children? 0 to 14. Come, children. At pH, you take a chemical, add universal indicator. What happens? Color will change. What happened to that color? It becomes dark red. pH will be 0. At the pH value 0, which color is mentioned there on the chart? Dark red. Then we say that pH is 0. Understood? When you add a universal indicator to a chemical, instead of dark red, it shows red. Take that red color solution, bring it on the pH chart. It will have different colors starting from 0 to 14. It will have different colors at different pH numbers, value. Understood? Thereby we can measure the relative strength of pH. Now, when you bring the chemical to which universal indicator is added, it shows some color, red. Bring it here. 1, it shows red. It indicates that the pH of the solution is 1. When universal indicator is added, it becomes light red. You bring it and compare the color here. The color will match the third column, which is that whose number is 2. Then we say pH is 2. Similarly, for orange red, pH will be 3, pH will be 4, pH will be 5 for orange yellow, 4 orange, 5 greenish yellow, 7 green. At a pH, if the solution is greenish yellow, bring it near the pH chart color. It matches with the color with the number 8. Then we say pH value is 8. Similarly for blue 9, then navy blue 10, purple 11, dark purple 12, violet 13, bright violet 14. Understood, children? Can remember properties of acids. Acid turn blue litmus paper red, isn't it? When the solution is red, we say it's an acid one. If it is dark red, it will be 0. See now, pH further it will decrease. Which is a strong acid? One with pH value 0. Just we discussed. I said it will come for one more question in MCQ. Which is the strong base? Whose pH value is 3, 5, 11 or 13. Which is strong base? 2, 5, 11, 13. One with pH value 13 is a strong base. Which is the strong acid? 2, 5, 11 or 13. 2 is the strong acid. Yes or no, children? As the pH value decreases, stronger the acid. If pH value increases, stronger the base. So, we take the pH color chart, we take a chemical, we add universal indicator at different pH value, they show change in color. That color we match it on the pH chart paper, then we find the respective pH of the given chemical. Understood, children? This is about universal indicator, another small topic, children. So then, this is the end of the topic. We will go to the next topic.